brought to you by MuleSoft, provider of the industry-leading AnyPoint platform for APIs.
I just want to make a few opening remarks about what we're talking about here. The news of breaches has reached in the mainstream press of big companies, Fortune 500 companies, and so on. It's now almost like an every week occurrence, and essentially what you have happening is that someone somehow is either accessing a programmable interface or creating one, and then working off of that, because these attacks that you read about are generally speaking of no use unless they really scale, right? And that's what the hackers, if you want to call them that, are after, is something that can scale, something that can something that represents their agenda at scale, and there are a variety of agendas out there. So API security is absolutely fundamental, not only to those of you who are API providers and providing a service, but fundamental to the security of the entire internet. If this problem doesn't get solved, and solved soon, it's going to be, we're going to have several disasters on our hand. If we don't already think of some of the things that happen as disasters. But I would venture a statement that some of the attacks we've seen, some of the outcomes of those attacks that we've seen, pale in comparison to what we might see. The reason I've invited this panel up here to talk about this issue is last fall we had Buffer, who provides, I don't even know how to do the one-sentence description of it, but I'll take a crack at it. They're sort of, they will make posts on your behalf to any of the different social networks, and they'll even schedule those posts.
Good enough.
Good enough, thank you. And so there was a breach of Buffer's infrastructure that was incredibly sophisticated and speaks to the lengths the hackers will go to achieve their agenda. When we first wrote about it on ProgrammableWeb, we called it the Buffer attack, but quite frankly, it probably wasn't the Buffer attack. It was just one attack that was downstream, that we theorize is downstream from a previous attack on Adobe's database. And to this date, we still don't know where that attack is going to lead. A lot of press came out of that, but nobody was really held accountable for it. A lot of people said change your passwords, that sort of thing. But in the end, that attack on the Adobe database is actually a gift that's probably going to keep giving for a very long time. And we just don't really know where it's going to lead. So I have Sunil Sadasivin, who is the CTO of Buffer, and he's going to talk a little bit about the sophistication of that attack. We have John Bradley from Ping Identity, and John is also on the OAuth Working Group, and we'll talk a little bit about the work that the OAuth Working Group is doing to help secure APIs. We'll also talk about what's going on in terms of standards in the way APIs are secured today, which vary from one API provider to the next. And in some ways, that was one of the areas of vulnerability in the breach of Buffer's infrastructure. And we have Adam Dawes from Google, specifically from the Google authentication team, because I think if you watch the press actually in the last couple weeks, there's been a rise in the interest of the idea of getting rid of passwords altogether, or as much as we possibly can to solve this problem. And Google is probably as far along in the thinking and implementation of infrastructure to achieve that, that dream, if you want to call it that, than anybody. So first, Adobe's database was attacked. We'll talk about the exact nature of that. Was that the user IDs were revealed and the password hints were revealed, and what ended up happening was a lot of people were able to determine, or hackers were able to look and see if you could see 30 or 40 password hints that were roughly the same. Guitarist for the Grateful Dead, let's say. You could run a pretty reasonable chance of hacking into all of those accounts. In fact, there are services on the internet now where you can plug your name in to find out if, you can plug your ID in or your email address to find out if you've been pawned, right? If you've actually been compromised or not. Incredible to me that this is actually taking place. So the nature or the problem here is that, is there anybody in this room who isn't using at least one of their passwords for 2 or more services? Anybody? A couple people, 3, 4 people. You're all using, for every service you use, you have one password. Or you're using some external form of authentication like a Google, Facebook, login, that kind of thing. The problem here is that once you've discovered a shared password, once the hackers discover that, and on scale can penetrate accounts, then crazy things can happen from there. I want to point out that the potential damage is significant. What I mean by that is, I don't know if everybody remembers, but the AP's Twitter account was hacked last year. And when it was hacked, they reported that there was a bombing at the White House. And that it wasn't clear on what the outcome of the bombing was. And immediately the stock markets dropped, like immediately. That was one tweet on one hacked account. Imagine what happens when you end up with a hack to tens of thousands of Twitter accounts or Facebook accounts, what the damage could have been done. And that's what the end result was in the case of the Buffer, the breach on Buffer's infrastructure. I'm still not clear on what the agenda was because it couldn't have been a weight loss scheme, which was what happened. What happened was, how many accounts were compromised?
So we ended up, I think it was around 400,000 Twitter and Facebook access tokens. So they could have posted to, roughly 400,000 different accounts. The breach lasted, or at least the spamming lasted for a period of 10 minutes. We were able to, luckily, just kind of shut that down immediately. We decided to pull the kill switch on our app for the time being by resetting our Twitter client secret. And then Facebook, we had to put our app in sandbox mode to just kind of stop the posting. And so within those 10 minutes, it was about 30,000 people who had their accounts kind of spammed. And it was all this kind of magical fruit weight loss spam. But yeah, it could, as you said, it could have been much more cynical.
You know, one of my thoughts was maybe this was not really a weight loss scheme. Maybe it was somebody was developing a botnet and covered their tracks pretty well once the thing was discovered. We don't know. And that's why it could be one of those gifts that keeps on giving. People clicked on the way. The way this worked is if you trust me and then you saw me saying something nice about this weight loss scheme on my wall, you might click on it. And I just find it implausible that the goal was to propagate a weight loss scheme. So let's talk about, so what happened after, let's assume that you were downstream from the attack on Adobe's database. What happened next?
Yeah, so this could have really been a lot worse than it was for us itself. So for me at Buffer, I kind of was on that day. It was October 26th, and I remember just kind of checking my Twitter stream, and I see all this weight loss spam, and I'm like, oh crap, like because I see it's from Buffer itself. It's on on Facebook. You see that it's via Buffer, and it could have been a lot more of it could have been a lot more staggered and everything. Yeah, so we kind of got online. My team was pretty small at the time. We were 8 people, 3 developers, so quite a small team, and we had no idea how this occurred. We were completely baffled. We triggered the kill switch, but we were kind of lost. We had no idea, and we were kind of looking for anything from like maybe they had SSH access, maybe they had some sort of way to grab these access tokens, and we received an email 2 days later from MongoHQ, and they let us know that there was an administrator account who was using a shared password, and that shared password was compromised, and that administrator had their Twitter account and a few other different accounts kind of compromised.
So Mongo HQ is the database that you guys use,
That's
right?
right. Yeah, they're a shared database hosting provider.
And
at the
an
time.
administrator at a Mongo administrator, somebody who works at Mongo, because they were using a shared password,
Exactly.
maybe something that was mined from the Adobe attack, they got into your database.
Yeah. So we know that with that password, that was the same password that they used with the Adobe on Adobe services, and so we're speculating that it's Adobe attack. It could have been a different attack as well, like Yahoo. I saw a couple weeks ago eBay also has had their database leaked with passwords and everything, but we're kind of speculating that it's Adobe. But yeah, so Mongo HQ, they're a platform as a service, and they house data for us and so many other different services as well. And they ended up scraping some 400,000 of our access tokens. And
these are the OAuth tokens used to make posts
yep.
on behalf of your users to Facebook and Twitter.
Yes, exactly. But they also went to so many other different services and kind of scraped a bunch of different things around that. There were SSH keys that were scraped from Mongo HQ, and so this attack could have been, and it probably has propagated a bit farther than what we have. Ours was the most visible attack because obviously you just see on Facebook and Twitter, all the spam.
They scraped. So just to give you an idea, they got access to an administrator that worked at Mongo who had basically backdoor access for support reasons to your database. Mm-hmm. And they automated the paging of a display through the database and scraped all this information of the users and their tokens off the screen.
That's correct, yep.
Just give you an idea of how the trouble these guys went to. Okay.
Yeah. And I mean, so just to give you some context, so the Adobe breach was, I think, beginning of October. On October 19th was when we saw the first access through the Mongo HQ console to our database. Mongo HQ was really great. They logged every different action, so we could see all these different steps that took place to get through. And so one thing is that 400,000 access tokens. The queries that they were doing were unindexed, so they take quite a while to scrape 400,000 access tokens. It was running for the course of maybe 3 or 4 different days to grab that many. And it really didn't stop there. So in order for them to have posted onto Twitter, Twitter uses client-side authentication for each API request. And so you need to provide your client secret or at least prove that you have a client secret to post to Twitter. And it took us actually a couple days to remember that they had this, and we realized that it wasn't just with Mongo HQ. It was our client secret was stolen, and what we did was we were storing the plain text client secret in our source code repository. It's just something we did from the very beginning, even before I joined Buffer, and there was no real. I didn't see. If you asked me before this hack, I couldn't tell you why that's a bad idea. It's just it was just 3 people who have access to that GitHub repository. 2 of us had two-factor authentication on it. 1 of our team members didn't, and they were using a shared password, and they were able to breach our GitHub repository through that 3rd team member. So
So just to review, shared password hit you twice. Once on the MongoDB breach, once on the GitHub breach, and we can kind of trace that back to what Adobe.
Yeah, the second shared password was also one that was used on Adobe as well. So that's kind of why we're inferring that. And yeah, we worked closely with GitHub as well to try and figure out and trace back what exactly happened. And this was a thing that was really scary for me. I mean, it was a nightmare all around because every day we would discover something new. So it's about a week after the initial kind of spamming, and it was, so GitHub provided us the access logs for what the spammers kind of looked for in our repository. First, they kind of poked and prodded a bit, just kind of looked for, just try to understand the app. And most of the stuff that we have there isn't really, we're not too worried about. It's not proprietary or anything. But then they started searching for things like AWS keys, AWS secrets, root passwords, database password, Stripe keys, basically anything of value, anything that could be used to potentially propagate. Maybe they could sell onto black markets or anything. But if they had access to your AWS keys, they could do a number of different things. They could turn all your servers off. They could maybe just spin up several hundred large instances and start mining Bitcoin or whatever. So it was, they could have done a lot more, and it seemed like that's what they were after. I'm not sure if it definitely didn't seem like it's just one person. It seemed like more of an organization or so, because we had four unique sessions all across the world open when we first realized that our GitHub was breached. And so it seems like it was more kind of like an organization that was.
There was also some traffic on Twitter, because when you locked it down, wasn't there somebody who posted a tweet looking for advice on how to break in?
Yeah, we did a little bit of forensic investigation on ourselves. We log things like API requests and everything. And MongoHQ, Facebook, and GitHub all had the same IP address for one of them. And so we did some forensic investigation. So we're able to connect API addresses to Twitter accounts because if they use Buffer.
And this guy used Buffer, which is kind of
he used Buffer, yeah.
One mistake, he was unable to cover his tracks.
Yeah, and very timely, and it was, it seemed like it was more of an anonymous account, I guess. But very timely message, maybe on October 27th, the day after, is like when we turned on, October 28th, when MongoHQ turned on, realized that we turned on two-factor authentication for our GitHub, and so they posted that like, help, I haven't been able to get past like text message verification or something. Does anyone have any advice or something like that? So we provided all this evidence to the FBI and everything to get there. We decided to kind of let them do the investigation and us focusing on hardening. But this was really more of a wake-up call for us. We took a lot of things for granted. We took a lot of like web security passwords. Two-factor authentication really was one of those like, not really. It's might add like an extra second to our development flow, so let's not enforce it among our organization or anything. But we, after going through this breach, we extracted anything we could think of from our repository. We reset credentials. We we made security way more of a priority. We think about it every day now. But I probably wouldn't be here talking about security if we didn't go through that hack, and I probably would be more in the audience, kind of skeptical of like still not sure of what to do. So obviously going through a hack really changes your perspective on things. But some of those learnings are really important. So I'm glad we get to kind of talk about that today, because.
And I just want to point out that Buffer and Sunil in particular have been uncharacteristically open about this experience, sharing everything when they could have gone on the defensive just to go into spin control. Just among this group, I think they deserve a big round of applause for how they're using their experience to help educate the rest of the industry and make the internet more secure. That is in the spirit of the internet, but we don't see it nearly as often, and it's great to have you here, Sunil, for that particular reason.
I think Adam just asked like how our users kind of reacted to that as well, and it was, I think your intuition when you go through a security breach is to hush it up. It is to, you want to kind of cover your ass a bit, and we were lucky. I wouldn't say we're lucky, but like, this was a highly visible attack. So in order for us to gain trust from users, again, we had to be transparent about it, and we had to be open about it. And so on the same day, we had a blog post that like would just say like, oh, like we turned off the app. Oh, like we realized MongoHQ had access tokens. And at that time, we thought we were secure, but we weren't. And then we had to finally put a post that our GitHub was also breached and everything. But I think the community response has been very positive, and I think all organizations, because I think there's going to be a ton more. Almost every 2 weeks I read something about the security breach, and most of them don't really explain too much, or they don't say exactly how it occurred. But the only way we can stop these types of breaches is by talking about it and saying exactly what happened, so we can kind of piece together and learn from it.
John, you're on the OAuth Working Group, and one of the things that happened here was to make these posts on behalf of the tens of thousands of users that were made, the OAuth tokens that were associated with each of those users for the different services, Twitter and Facebook, were stolen and then used essentially the way a user ID and password would be used to make a post on behalf of those users. How is that possible? How is that possible? What about the token was so insecure that that was possible?
Well, a lot of the initial reaction was that OAuth was somehow at fault. But if you step back and think about it a little bit further, if Buffer had, like Adobe or eBay, etc., had all of their usernames and passwords compromised for all of those users for all of those services, if they had actually been storing the usernames and passwords and those had been taken, the amount of time, well, you probably wouldn't be here. You would, well, or you might be here but looking for a job.
Yeah, I would not be.
So the point being, they got the tokens, but they did not get the user
usernames and passwords.
Right.
That Buffer was able to, if they had gotten the usernames and passwords, they could have created their own clients and run off and created. There would have been no way for Buffer to have stopped that attack.
Right.
The idea behind OAuth when we first created it was to stop people from having to give usernames and passwords to all of these sites for enabling API access to these valuable services that were popping up, like Twitter. So Buffer was able to stop the attack inside of 10 minutes, which is pretty good. Not, if it had been 0, that would have been ideal. And they were also able to recover from that in a fairly simple way. In some cases, it was just changing their client secret, which was compromised. Stealing the tokens wasn't enough for Twitter. They also had to get the client secrets. In principle, if Facebook had been more upfront about how to properly configure their security, which is an issue at Facebook, they tend to talk, they have nice, happy developer documentation, which doesn't talk about any of the security issues.
I just want to stop you there so we can talk about the client secret. When you have an application that is authorized to run on Twitter or on Facebook, they give you a secret.
Yes.
That's supposedly something that only you and they know, you and Twitter or you and Facebook. When somebody makes a request, an API request, and supplies the OAuth token, you also supply that secret, because theoretically you're the only one who knows, as proof that you should indeed have the right to use that token.
There are some small differences between,
medium-sized
differences between OAuth 1, which is what Twitter is using, and OAuth 2, which is what Facebook
is using.
Yes.
When I went to set up an app in Twitter, I discovered, and we had a conversation about this, that in the case of Twitter, no matter what, they require the secret. That's it. It's required. No, you can't get around that problem.
Right.
But in the case of Facebook, there's a checkbox that makes it optional. In other words, the provider of the app can say, nah, don't worry, we don't want to make it required that the API call was going to require also the caller to supply the application secret,
right.
Which by itself is kind of like, wow, wait, why do that? Why leave yourself open to that sort of thing?
It's actually off by default.
It's off by
It's
default.
off by default. There's a number of security things that are off by default in Facebook. For their own clients, they turn them on, but for third-party developers, they don't necessarily make a big deal about what those are. So in OAuth 2, in principle, you have very short-lived access tokens and something called a refresh token, which you trade for. You use your client secret and your refresh token for that particular user to get a new access token. The access tokens are used and then thrown away. They ought not to be kept permanently. Facebook made a decision earlier on not to use refresh tokens, which turned out to be a security problem, so they sort of backfilled with doing a signing request on the
so just to be clear,
API access.
best thing to do is make sure you're using refresh tokens.
Best thing
so
to
that
do.
so that in the case of a breach of this nature, the token might be good for for a split second, but after that, it's no longer good anymore.
Right, for a short period of time. Now we are extending OAuth to use something called proof of possession, where you can also extend the security around those access tokens so that only the actual client that they were issued to can use them in a similar way to Twitter. Now, Twitter
so essentially, we're saying, whereas before we don't have a standard for showing the client secret, in some ways, is the thing that is a proof of possession, but there's really not a standard for that per se, like a standard best practice or standard anything. Just looking at the difference between the Twitter and the Facebook implementations. Where you're going here is creating a standard for proof of possession in hopes that everybody will embrace that.
And being able to actually use asymmetric keys and perhaps secure those secrets in, if Buffer had their client secrets in a secure storage device, TPM or HSM secure storage device, which Amazon is now willing to lease you for only an exorbitant amount of money. Yeah. Hopefully we can drive those prices down as more people require that service.
Let me just stop you there. So everybody in the room is clear on that bit of architecture, which could really lock things down. Your GitHub repository was compromised. Mm-hmm. In your source code, you had your client secret in plain text. Where you had that client secret, it could have called a TPM or an HSM that would have had that completely encrypted and essentially impossible to get at. I mean, nothing's impossible, but the barrier to entry there would have been.
They would have had to have broken into Amazon and stolen the device.
Right.
Access or something.
And so we're talking about using a separate server altogether to encrypt that. So it's another layer in the infrastructure that's apart from where the code is running or anything like that. That's an option for everybody, but it's not an inexpensive option. It's a very expensive option.
So there are projects. There's an open source project to actually create sort of a mass market HSM storage devices that people can use. But at the moment, the prices for those secure modules, because they're sort of military grade pieces of equipment, only large companies tend to buy them. So the manufacturers know that. So we're trying to drive down the price of doing that. Even keeping the keys in the standard Unix key store, Linux key store, et cetera, is a big step beyond leaving them in a file that can be accessed by somebody who gets SSH access to the server. So the better you can secure those keys, the less likely they are to be stolen.
So going back to the standard, so now you're arriving at a standard way to just deal with the proof of possession issue in hopes that all API providers will just immediately embrace that.
Right. So there are a number of issues. Depends on the kind of OAuth client as well. That
Mm-hmm.
I mean, we at one time everything was sort of a monolithic web server application that was using APIs. That isn't the world that we live in anymore. That's one of the reasons why we moved from OAuth 1 to OAuth 2 is because now we have native applications on phones. Shouldn't use OAuth 1 on a native application on phone. It was never designed for that. There are lots of security issues. We have JavaScript that's executing in the browser. A lot of people are doing, that's sort of the next wave of development is HTML5 in the browser. The difference between a web SSO and an API access is mostly in the mind of the beholder. That essentially what you need is some sort of access token for doing a REST call, which can either be a cookie or an OAuth token. It's really 6 of one, half a dozen of the other. So securing both the web browser environment and the native applications environment are also parts of that puzzle, because we want to keep the actual resources abstracted from the different kinds of clients that are going to be accessing them. We don't want to have to tell API developers, oh, develop 3 kinds of, you have your SOAP infrastructure, which we told you to do 4 years ago. Now we have REST, but you have to do 3 different kinds of REST for 3 different clients. That doesn't make any sense. So we have to be able to firewall that off so that clients can have a simple security model that can work either from browsers, from web servers, or from native applications.
Mm-hmm. So when all this happened, and I was working with Sunil to just basically understand more of the nature of the attack, I really had that aha moment where I was like, wow, I don't know how many services I access. Here's one other big challenge of securing the internet. Not a day goes by where I don't get some other invitation to try another service out. And I go in there and, okay, put your username, come up with a username and a password. We have that on ProgrammableWeb. The truth of the matter is we're all acting on blind faith. We have no idea who we're giving that information to. We have no idea. To your point, Sunil, well, we discovered a bunch of best practices that we should have been doing, but we weren't. We really have no idea what best practices are in place at these different security providers. You could be giving a password to them, which is a shared password, and they just may take that shared password and go off and do something with it. You have no idea what their true agenda is. It's pure blind faith that almost all users of the internet are acting on. And I had that aha moment thinking, I don't want to supply a username and password to anybody anymore. I want to be done with that. And when I was talking with you, John, and with you, Sunil, it suddenly dawned on me, we can, through this type of infrastructure, pretty much get rid of all these usernames and passwords, with the one caveat being we have to place our trust in one authenticator. Now, Sunil, you were talking about how you guys you had 3 developers. 2 of them were using two-factor authentication to get into GitHub. A third was not. That guy had a shared password. That's how they got in there. But GitHub is one of very few services on the internet. I don't want to say very few. I haven't done a count. You might have a different count. But broadly speaking, you go to a lot of services, you don't see this capability, that supports Google authentication where two-factor authentication is required. In other words, I log in with my Google authentication, and then I'm sent an SMS on my phone, and only the person who possesses the phone then actually gets access to the service. So technically speaking, and I'm not suggesting that Google should be the only one of these, but technically speaking, if we can place our trust in one authenticator, and they provide this two-factor thing, we can pretty much, with the exception of one username and password, rid ourselves of usernames and passwords.
We're trying to fix that one too. We ideally would like to have a Google login experience where you don't really interact with your Google username and password, but rely on other factors to get you logged into your Google account. But I mean, your opening question to the audience, I think, highlights it. I mean, this is a very sophisticated crowd here, and I think 3 out of, I don't know, 100 or more people are diligent and have good hygiene about having a different password for every single site that they use. And I think
3 out of 100 is not a very good report card, though. So,
no, it's terrible. And this is an extremely sophisticated audience.
Yeah.
I mean, you go out to our mothers, and it's probably 100 out of 100 are reusing massively. My mother may only have one password.
And it's 1, 2, 3, 4, 5, 6.
And it's pretty weak, yes. So yes, I mean, I think that is the heart of the problem, and I think using federation technologies and security, probably one of the more well-used security techniques is defense in depth. But there are other sort of strategies, and one is to actually put all your eggs in one basket and guard that basket very carefully. That's sort of like the guarding the president kind of metaphor, or an aircraft carrier. They have a huge force field around them. If the internet can grow its usage of federated identity, and users can then decide to place their trust in an identity provider and put all of their eggs in that basket of that identity provider, and make sure that that identity provider is got really good security and does a really good job authenticating me when I log into my account, then that's actually going to raise the security level tremendously across the internet. So that's sort of the vision that we're espousing, that we think the identity provider doesn't have to be Google. Our own two-factor authentication app that we distribute on actually both iOS and Android, it's open for other providers to similarly use that. So you don't need to have 10 different OTP apps on your phone. You can just use a single app, the Google app, which uses a standard to generate these OTP codes. and you can use that for all of your different services. So we really think that raising the bar and having these multi-factor authentications, not just necessarily with the phone, is definitely the way to make progress in lowering the scourge that is password reuse.
Where does the work you're doing intersect the API work?
So I actually work a lot on the API side as well. So I work on the OAuth team and the identity team in general at Google. It's really our mission to lower the friction that users feel, or the friction around authentication on the internet. So that's both increasing the security of a given session through things like Twofactor, making that as easy as possible, as good UX as possible, and then as users travel across the internet, really minimizing the amount of login friction that they have to go through. So clicking a button, doing a federated login is a whole lot easier than remembering a username and password or generating a unique username and password. Doing OAuth requests, to get access to user data instead of having that app ask for your username and password. We do a lot on the defensive side as well, protecting our own infrastructure against logins. We have crossed a threshold a number of years ago where username and password was the only thing that was required to get into your account at Google, even for the regular user. Now we kind of take more of an approach like the financial services industry does, which is a risk-based approach. So before you transfer money out of your bank account, the bank goes, how sure are we that this is really a legit transaction? And they have all these calculations and analysis to try to determine that. We're now in the business of doing that every time you log in, whether you're a two-factor user or not. So we see strange patterns in your login behavior. We see excessive numbers of login attempts, distributed login attempts. Those are signals for us to present additional challenges for users.
And I've seen this happen. Like my browser will be up and running, and I'll be open at Gmail, and then I'll come back to that same tab, and it will have logged me out. My assumption is there was a signal that you received somehow that said there could be something funky here, so challenge him one more time before you give that access.
Yep. So we've invested tremendously in that, and our view is that security is unfortunately it's not trivial to do and to do well, and I think Sunil provides a great example of kind of the typical company and how they approach security. Our view is that unless you really have hundreds of people that are managing your security of your login system, your API system, all of that, you're probably got quite a few holes that you've got to take care of. So the more that you can rely on standards and standard libraries and federation and the infrastructure of others that is well tested and well managed, then you're probably really exposing yourself to.
Well, but Heartbleed was a standard kind of library, if you want.
Heartbleed was definitely a big one.
Yeah.
So I think that is kind of, John can probably comment better, but maybe a once a decade kind of vulnerability. Let's hope so. That was so embedded across all infrastructure and was so serious. But I think the community has responded pretty well to trying to get that cleaned up quite quickly.
Is there a form of two-factor authentication for machines that can deal with this proof of possession?
Well, it's ultimately the client secret that is the app identity that is the identifier that the app uses.
There is a working group at the OpenID Foundation called the Native Application SSO Working Group, which is...
This is separate from the OAuth Working Group, right? So.
Separate from the OAuth Working Group, but builds on top of that, which is, on Android, there's the Play Store, which basically abstracts how applications get access tokens. So one of the things that is true is that people who are app developers may have a challenge even doing TLS properly. A lot of native applications don't properly check TLS server certificates and are subject to all sorts of interesting man-in-the-middle attacks. So moving some more of the responsibility of how the applications get those tokens into a centralized service on the device is something that Google has done on Android, and we are looking at generalizing that for other operating systems. Layer 7 and Secure Key and various other people are working in that work group to try and do that level of abstraction where the token agent on the device can look at the signature of the app, make sure it's the correct app, and perhaps have a higher level of authentication, perhaps build that multi-factor authentication directly into the communication with the actual authentication authorization service, so that not every application has to reinvent the wheel.
Right. Sunil, you've put a bunch of best practices in place. You're sleeping any easier now?
Actually, no, not really. So
there's no rest for.
That's one of the biggest learnings, was that security is not like development. It's not like you're finished with your task and you're on to the next thing. It's very much, there's all these new attack vectors just kind of happening all the time. Heartbleed is a great example.
They're relentless.
Yeah, exactly. And so I think I've kind of just studied over the past 6 months and interviewed just different types of people, just wanted to understand how we can prevent this. And it seems like no one has a silver bullet. It's just the best organizations are the ones who continuously think about security and are the ones who will jump on things like Heartbeat immediately and just kind of get that out of mind. I do want to add that I think one of the things that we learned that was really important was getting our whole organization on board and to buy into security. And it was easier for us because we had this hack to point to and be even for newcomers, maybe a new support person on board, we tell them about the hack. We have this huge write-up, and we give them some articles to read and stuff. Each new person on our team has access to things like our Stripe dashboard, and there's no, and some of these services that we have, they're fragmented. So the way that some of them don't have two-factor authentication at all, or some of them do have two-factor authentication, but there's no way to enforce it. So you have to. So I'm kind of the security person to every week or so, I'll just double check our our Stripe dashboard to check if everyone has two-factor turned on, and there's a little check mark. And same thing with GitHub.
When you say this is just a really important issue for service providers like Stripe, what you wish is from an enterprise level, they provided you with some administrative functionality to enforce. Because if you're not able to enforce, you just have to either double check it on a regular basis or trust all your people to be doing the right thing.
Yeah, those are all holes. It's my turnaround time to double check, right?
So compliance has been a big issue in financial services and health for a long time. Now, whether or not those compliance audits and such actually produced useful results, at least it got people thinking about that. I think that looking at what sort of compliance reporting, being able to get audit logs from your service providers, be able to actually have some visibility into that security is going to expand beyond those sort of regulated markets into what people expect from cloud service providers. Yeah.
Okay, well, we're out of time. This is just another one of those topics that I think we could have spent a whole day on. We could do another conference on API security by itself. My objective here was to show the relationship between username password security and API security. The two, in your case, were directly linked to one another in a way that resulted in something that all of us need to be battling against every day. We have to be vigilant about it. And if we can win that battle, or at least make significant progress in that battle, the internet will be a far more secure place than it is today. So I want to thank our guests here. Thank you very much.